Ladies and gentlemen, I can introduce myself. My name is Ian Young and I'm the Vice-Chancellor of the Australian National University. Before we begin, I'd like to acknowledge the first Australians on whose lands we meet and whose cultures are among the oldest continuing cultures in human history. Deputy Chief of U.S. Mission, Mr Jason Hyland and Mrs Hyland, ladies and gentlemen, it's a great pleasure to welcome you here today to the ANU. This afternoon I have the immense privilege in welcoming our guest speaker, retired Marine Corps Major General Charles Frank Bolden Jr. Administrator Bolden's 34-year career with the Marine Corps included 14 years as a member of NASA's Astronaut office. After joining the office in 1980, he travelled into orbit 4 times in space shuttle flights between 1986 and 1994, commanding 2 of those missions. His flights included the deployment of the $1.5 billion Hubble Space Telescope and the first joint U.S. Russian shuttle mission. Administrator Bolden began his duties as the 12th Administrator of NASA in 2009, leading the NASA team and managing the resources to advance the agency's goals. ANU and NASA has a long and strong history of collaboration in many exciting endeavours, and I'd like to just mention a few of these. ANU Emeritus Professor Mike Doppiter is currently working on the Scientific Oversight Committee of the Wide Field Camera, which is one of the instruments installed on the Hubble Space Telescope. For the past decade, NASA has financed the ANU Sighting Spring survey of near-Earth objects. Together with partner observatories in the US, 90% of all asteroids 1 kilometre or more in size, which have approached Earth closely enough to potentially collide, have been catalogued as a result of this project. The Endeavour UV Space Telescope was developed by astronomers at the Research School of Astronomy and Astrophysics and built by Ozspace Limited. The instrument was used on 2 space shuttle flights in the mid-1990s. The NASA Grace follow-on mission, which ANU students and staff are involved in, is scheduled for launch in 2015. The project will develop laser ranging technology and analysis capability for Australia to measure polar melting rates and to monitor continental water resources, providing insight into climate change impacts on our region. The Grace follow-on mission project is supported under the Australian Government's Australian Space Research Program. I'm also very proud that one of our students, Lyle Roberts from the ANU College of Engineering and Computer Science, has been announced by NASA as the winner of the 2011 Victorian Space Science Education Centre NASA Australian Space Prize. Lyle will spend 10 weeks at the NASA Ames Research Centre as part of the NASA Academy program. He will meet leading NASA scientists and engineers and work on a current NASA research project called Understanding Warning Signs of Major Earthquakes. As is evident in the research collaborations between ANU and NASA, we share close ties with our scientific colleagues in the US, and I sincerely hope that we'll be able to continue to enjoy those ties for many years to come. Ladies and gentlemen, please now join with me in welcoming Administrator Charles Frank Bolden Jr. to ANU.
Thanks very much. It's a pleasure for me to be here. It's been a whirlwind day. We started this morning at, I don't know what time, but we left Sydney and flew over here, and it was a really quick trip, and it has been an incredible day that it keeps getting better. I have 2 rules when I go somewhere to talk, so I'll tell you what the 2 rules are, and they're really easy. Thomas, this is for you, all right? And I see there are 2 other, at least 2. How many people here who are not at the university in one way or another? Any high schoolers? Okay, one. What's your name?
May.
Meg?
May.
May. And then you're elementary? First grade? What's your name? What grade?
Grade 4.
Grade 4? And what's your name? Luke?
Lucas.
Lucas. And how about you?
Leo.
Liam. Liam and Lucas, are you all brother and brother? Related? No, just friends. That's good. It's good to be friends with somebody. And Thomas, you're 7?
Yeah.
Okay. And I want you all to meet sometime tonight my new friend who's going to talk about trans-Neptunian objects, or what else do we call them? Dwarf planets and all that other kind of stuff. Okay. 2 rules. Rule number 1, ask questions anytime, okay? I think they have a formal question and answer period set aside later on. If you wait until you got me saying trans-Neptunian all the time now. If you wait until the formal question and answer period, we won't do it because I talk too much. So we'll just run right through the question and answer period. So that's rule number 1. Rule number 2, there is no dumb question. If you can think of it, it's worth asking, okay? No dumb question. You cannot possibly think of a question that you want to ask that probably someone else... Dumb question? Oh, question already. I'm sorry.
Hopefully not a dumb question. Since you're inviting us to ask questions, I was just curious, do you have any deadline for the James Webb Space Telescope?
Oh, deadline. James Webb's going to be launched probably October 2018. What we had, for those of you who may or may not, I know there's somebody here who's working JWST. Are you working JWST? Okay. JWST, the James Webb Space Telescope, is a follow-on to Hubble. And I will tell you very quickly, when I came in as the NASA administrator, I was not shocked, but I was disappointed to find that in my first year, I hadn't paid any attention, as the kind of attention I should have paid to James Webb. We were over budget, late in schedule, and a lot of other things. And so a person who has become a very dear friend of mine, Senator Nkosi, and I know this doesn't mean anything to any of you, but Americans in here will recognize, Senator Barbara Nkosi is the longest serving woman in the U.S. Congress as of 2 Saturdays ago, I think. An incredible friend of NASA, an incredible friend of the space program. She is one of the 2 state senators from Maryland and passionate about science and passionate about the Goddard Space Flight Center, passionate about Hubble, and passionate about JWST. And so she had us go off and empower an independent study group to take a look at James Webb to see if we could salvage it, to see if we needed to just cancel the program. I am a person who believes that JWST will completely transform our understanding of the universe even farther than Hubble has already done. So that's my personal belief. And what we did was we got the results from the independent study group. We took a look at what we thought it would cost based on what they told us we should plan for, and we submitted a replan to the Congress of the United States, to the President's office and everybody else, and finally got it approved. And so instead of launching James Webb in 2014 as it was planned, but we were not going to get there, we now, under the replan, are going to launch James Webb in 2018, and the budget is in place to do that, and the President's budget request for this coming year fulfills our need for funding this year, next year, and the out years to deliver James Webb by 2018. So hopefully that answered the question, okay? So you got the 2 rules? He showed you. That's the demonstration, okay? Now, second slide, I guess. NASA has 3 big things we do. We have what we call mission directorates. One is here, science, the Science Mission Directorate. We have 4 branches or 4 divisions of the Science Mission Directorate, and I'll tell you very quickly what they are. Earth science up on the left, where it's obvious, where we study mostly things, for example, like climate change, remote sensing, some of the stuff that the science program here in Australia happens to be very interested in, has decided in their new space policy that they want to devote money and time and effort to. Astrophysics on the right, that's one of the many images from the Hubble Space Telescope. I was with a group of high schoolers this morning, and I said, astrophysics, and somebody sitting right where you're sitting went, yes! And I said, man, this is a group of high schoolers? I've never had a high schooler say yes about anything. I mean, you all were high schoolers once, remember? You do not express a show of enjoyment, interest when a speaker comes. That's the last thing you do in high school, you know. Don't let them see you sweat. You do not want them to know you're interested in what you say. So having a high schooler say, yes, about astrophysics, I went, did you really mean that? And he said, yeah, I love that stuff. And then when I went to the next one, planetary science, he went, yes! And I said, now wait a minute, you told me you were an astrophysicist. He said, I like it all. Astrophysics, planetary science, all that. And then finally, heliophysics. Since this is a really smart group, I always like to ask the question about heliophysics. What the heck do we do in heliophysics? Is there a heliophysics here amongst us? Or is someone who's interested in heliophysics? The professor says, I have a student. Or you're a professor? Yes? Heliophysics? Well, but you're not, that's not fair for you to answer. Do you have a student here who's going to answer this question? This is a test. The professor is going, please, somebody who's my student, tell them what it is. No students? Okay, what's heliophysics do?
The study of the sun and the environment that it.
Fantastic. I didn't realize you all couldn't see the Aurora Borealis from here. I thought you would be able to. Does everybody know what the Aurora Borealis is anyway? The Aurora Australis. That's why you can't see the Aurora Borealis. Trick question, trick question. And you gave me a trick answer and I almost bought it. The Aurora Australis. But I understand, don't see it from here, not very often. Okay. If you could, you would notice that this year, I mean, it's incredible. The last few months particularly, you know, we're going into a period of what I am told is solar maximum where the sun's really bubbling. I mean, it's doing all kinds of stuff. And Peter, now, do you know this? Thomas, not Peter. That's why you didn't answer. That's a trick question for you too. Now, has your dad told you all this stuff I'm getting ready to talk about? So I should not even waste my time doing all this? You know all this? You know about space weather? No? Good, okay. So I can say, you all know about space weather? No? Good, all right. Space weather, you know the stuff that comes, energy from the sun, all these particles, charged and otherwise and stuff. Earth has this thing that we call the magnetosphere, okay? Somebody want to describe the magnetosphere for me? What's it like? Not the professor. All right? If I give you a hint, a nut. What did you say?
Big donut.
A big donut.
Yeah.
That's a kind of okay. I can take that. I was trying to get you to describe it like a walnut shell. You know, something more protective. Donut, strong donut. That's right. Since most of you are college students, in your high school, you remember the teacher that gave you, you're looking going, yeah, I remember, no I don't. The teacher that gave you a sheet of paper and took metal filings and dropped it on the piece of paper and then put a bar magnet underneath the piece of paper. Or maybe if your school was really a rich school or something, they had a piece of glass. And, but you know, the normal schools, they use, okay, come on. But does anybody remember that? When you put the bar magnet under there, what do the metal filings do? Come on. He said it, he gave you the answer, the donut. What did you say? They go reorient themselves, and then they look like what? Like a donut that somebody scrunched down at the top and the bottom? You know, a C and a backwards C, like that? That's the walnut shell that protects Earth, that I call the magnetosphere. I think you all call it the magnetosphere, I hope. And anyway, its job is to protect us. So, you know, it keeps you from dying right now because of all these things that are coming from the sun and Jupiter and Neptune and everywhere else that I call space weather, that mess up your cell phone or that'll mess up your television if it were not for the magnetosphere. And because we're going into this period of solar maximum, you're getting all kinds of energy from the sun as it burps now and then. And the poles are kind of weak because the little C's go like this, you know. So they can't come in by the equator and they can't get in other places. But when they get up by the poles, they bend in and they just energize the atmosphere. And we get just incredible lights. And so up north, we call it the Aurora Borealis, and down south, we call it the Aurora Australis. And from space, it's incredible. If you have never seen it ever in your life, go to the NASA website, www.nasa.gov, and if it's not on the front page, then go up there and say space weather or Aurora or something like that. There are the most incredible images coming from the International Space Station of late, where the crews have high definition cameras on board now, and they're just recording it and feeding it down to down to Earth so we can look at it. And also some nighttime views of Earth that are sped up so you can see the lights of Earth at night, because in the daytime, you don't recognize that humans live here. Nighttime, it helps you understand it. So that's science. The next mission directorate, go to the next one. It's not the next mission directorate. It's a satellite called Juno, or a picture of it, an artist's concept. It's on its way to Jupiter. What looks kind of weird about that particular image of a satellite? Does that look like a satellite that you can think about? I mean, you know, what's different about it? Anybody? No?
It's a windmill.
It's a windmill. Well, that's pretty close. It's not, but you gave an answer. Yes.
So the bottleneck on money?
It's going to swallow all my money? I don't know. But the big arms are solar arrays. And normally for satellites that we send to distant planets, to the outer planets, to deep space, solar arrays don't work. You know, as you get farther and farther away from the sun's energy just gets weaker and weaker and weaker as a factor of the radius something, okay. These are new technology solar arrays, and we actually believe that by the time this thing gets to Jupiter, they will still be providing sufficient power to power the satellite. So something we've never done before, and it's an incredible mission. We launched it last year on its way to Jupiter, and it's doing incredibly well so far. Next one. These are twin satellites called Grail A and B, and a group of high school students from Montana. We had a contest to name the Grail satellites, and so they named them Ebb and Flow. Anybody want to tell me why they named them Ebb and Flow? Want to guess? Well, like I said, they're twin satellites, and they're following each other around the moon. And they're trying to measure the magnetic field, trying to map the magnetic field of the moon as they go around, but also trying to study as much as they can about the interior of the moon, we like to say from core to crust. And as they go around, when the magnetic field is stronger, then the satellite gets pulled down, the lead satellite, and the rear satellite can see that. As it goes lower, it speeds up. The upper one kind of lags. They tend to ebb and flow. Come on, that's not my name. The elementary school students thought of it. So ebb and flow, Grail A and B. But those are two. Next slide. This is I love it. This is the Mars Science Laboratory, Mars Science Laboratory, MSL, or Curiosity is its nickname. We launched it last November, Thanksgiving weekend in America. And it's on its way to Mars, 8-month journey. We'll get there on August the 5th, August the 6th, depending on where you live. We'll land it on Mars. It's incredible because it's the largest vehicle we have ever landed anywhere. The thing's the size of a Volkswagen. And it's going to be incredible. It has a nuclear power source that will give it, if we could keep it going that long, it could last for 55 years, riding around the planet. It's got a mission that's planned for 2 years. The hardest part of it is yet to come. Launching things from the planet, from here, is really hard. But this one, landing it on Mars, is really, 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 really hard. We don't completely understand the Martian atmosphere. It's got to descend through the Martian atmosphere, come to a hover with its retro rockets, so that it can then use a sky crane to do something else that we've never done before, gently be lowered to the Martian surface on cables. And once the cables sense that the thing's on the planet, then they'll release themselves at the rover, and the lander will go fly away and put itself somewhere else on the Martian planet, never to be seen again. It is absolutely incredible because it has a drill that actually, on an arm, that we can send out. It can actually take core samples from the Martian surface. It can go up to rocks because it's got a impact drill that can just ding, 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 just knock away little chips or dust from Martian rock. And we think that we're going to get some samples that hopefully will help us understand what's there. You say, what's there? What do you mean, what's there? Well, we're landing it in a place called Gale Crater, where we've had ice. So we think that what's there may be signs of life, signs that there could have been life, or signs that there could be life. And that's kind of one of the big questions that NASA asks for all of us all the time. Is there life elsewhere, in our solar system, or is there life elsewhere in the universe. So when people ask, why are we doing this? That's one of the reasons. It will take the samples, put them on its back. There's a little spectrograph, and so it puts it in there, and it gives you real-time data as to what it just sampled or sensed. The camera, the big arm sticking up, has a set of 2 monocular cameras designed and built by the company that's owned by James Cameron. If any of you are big buffs of, James Cameron, the cinematographer, producer, all that kind of stuff. So not only is he in the Mariana Trench, he's getting ready to be on Mars. And the cameras are color high definition. He's got a technique where he will be able to give us 3D images with the 2 monocular cameras. We worked right up until almost launch time to try to be able to fly a 3D camera that he had developed and wanted to fly, but we just couldn't get it there in time. But we're still hopeful that that's going to work. So that's science. The other mission directorate that everybody knows about and talks about a lot is called the Human Exploration Operations Mission Directorate. That's where all of our human spaceflight work is done, whether it's the International Space Station now as its big effort, commercial crew and cargo, the program with our heavy lift launch vehicle and Orion crew capsule that we're going to use for deep space exploration. And it's a combination of what used to be space ops, the space shuttle and International Space Station, all of our spacecraft communications and navigation, which is when you go out to Tin Bin Biller, that's a part of HEO, MD. The Deep Space Network belongs to them. And then we took the Exploration Systems Mission Directorate that at the time was trying to bring about the Constellation program that we terminated when I became the NASA administrator. So we're now trying to take the work that we were doing in Constellation and put it into a more focused program that we're going to be able to realize. First thing that you're going to see from it will be actually the launch of the Orion spacecraft in 2014, 2 years from now, as a part of a test by Lockheed Martin. That's the prime contractor for it. They're going to launch it, I think, on a Delta IV. And its only purpose for that mission is to get it out to a largely elliptical orbit that will accelerate it to the kind of speeds that we need to have a reentry similar to what it would be coming back from the moon or from Mars or somewhere, so we can see that the vehicle can, in fact, survive intact from a reentry that would be typical of what would be coming back from deep space. Then 2017 is when we're scheduled for the first uncrewed flight, and then 2021 is right now, the most likely date for a crewed mission. With our goals being to send humans to an asteroid in 2025. I tell you, you got to help me, okay? Because we got to figure out which asteroid, we don't know. And then eventually, as President Obama has challenged NASA to do, to put humans in the Martian environment by the mid-2030s. And that's, when I say in the Martian environment, what we're trying to do now is determine, okay, does that mean on the surface of Mars? Does it mean on one of Mars's moons? Put it on Phobos or Deimos? Or does it mean just going around and doing different things? So a lot of things we got to do before we can put humans on the planet, however. We need to understand the planet itself. We've got to understand the radiation environment between here and there so that we know that when a human arrives or humans arrive, they can function. We're not really worried about them dying en route because of radiation, but we are worried about single event upset. And I'm using computer terms here, okay? Because I think you all understand that kind of stuff. But the central nervous system is a big computer. And we're worried about impact of a long duration, an 8-month mission with humans just being bombarded with radiation in the environment that we know we've got to go through. So that's the big challenge for us. Thing that we could do as a countermeasure would be to come up with an in-space propulsion system that cut the mission in half. Instead of it being an 8-month mission, make it a 4-month mission. So there is still an opportunity for us to do that before it's time to go fly in 2030. Next slide. Then the third area is aeronautics. It happens to be the smallest piece of the pie in NASA. Science and human exploration are the two big pieces of our budget pie. And then there's a smaller piece that's devoted to aeronautics, which is really the way that NASA started. We used to be an agency that looked at aeronautics for the nation, and then as we started thinking about sending humans into space, it morphed through the National Space Act into the National Aeronautics and Space Administration. This is mainly for the youngsters who are still in school prior to college and graduate school and all that. All of you college students, you don't need these three pieces of advice I'm about to give because you already understand this, so you can just turn me off If you haven't already done it, don't pay any attention to it. Thomas, I need for you to listen. I need for you to listen. And I need for the high schooler to listen, all right? You got to study hard. Anything you want to do, you really got to study hard. Mom and dad are right, okay? I wish I could tell you that I'm going to bring you new news. I have no new news in my 3 pieces of advice. You got to study hard. It makes no difference what you want to do. You've got to really study hard. Now, kids ask a lot of times, I want to be an astronaut. What do I need to study? I tell them, doesn't matter what you want to be, you really do need to put a lot of math and science in your curriculum if you can, because it's going to enable you to be flexible as you go along. If you decide you want to be an anthropologist, or you want to be a writer, or you want to be an actor or a musician or something, and then you get halfway through college and say, I think I want to be an engineer. If you don't have the requisite math and science background, you don't have the flexibility to make that change. So I encourage everybody to take as much math and science as you can. Take liberal arts courses as much as you can. Take foreign languages if you don't already. I'm an American, as you all know, so my foreign language is English. I have a hard enough time with that, but so I don't practice what I preach, because I tell my granddaughters, and they are listening, they do speak foreign languages. I tried it when I was younger and I failed, and so it's not too late, but I don't really speak adequately a foreign language. But you need to be able to. And if for no other reason than when you learn a foreign language, you also learn the culture that goes with it, and it's always good to understand other people and other cultures and other forms of ways of life. But I showed this airplane because in aeronautics, it's called the XV-15. It's a really old airplane. It was the first tilt rotor that we seriously looked at flying. And as you're now about to get United States Marines into the northwest part of the country periodically, the way we used to do a long time ago, you're going to see a funny looking airplane come in with them that's called the Osprey, the MV-22. And it's a tilt rotor, it's a tactical tilt rotor airplane. It can go 300 knots straight and level, almost like a jet. And then it takes off and lands like a helicopter. So it's absolutely incredible. And it all started with the XV-15 a long time ago, back in the 70s at NASA Ames Research Center in Mountain View, California, sort of a joint project between Bell Helicopter and NASA and later the Department of Defense and DARPA. Next one. Second piece of advice. Don't worry, you only got 2 more. This one and 1 more, all right? You got to work hard. Now, what do I mean by that, Thomas? Don't know? You take music yet? Piano? No? Either one of you take piano or violin, or you play sports?
Yes.
What do you take? What sport? Soccer?
Yeah.
Your soccer coach tell you got to work hard if you want to be good? All right? How about some of you college students? You do any of this stuff, For you graduate students, did your professor, your advisor say you really got to work harder? You don't have any option? You really do. You have to work hard. Anything, again, if you want to be successful, you have to work hard. And mainly what I mean is focus. When you're in the classroom, just focus on the academic work that's in front of you, whether it's math or science or anything. And then when you go to do something else, you should work equally as hard. If you're a musician, when you go out to the band or the choir or whatever it is, really work hard on that if you want to be the best. So that's what I mean when I talk about work hard. I picked this airplane because it was a very difficult airplane to fly. What's wrong with it? Nothing. Wings are on backwards. Other than that, it's nothing. All right. But it's a very heavily augmented fly-by-wire aircraft that NASA used to fly out at the Dryden Flight Research Center. It's called the X-29. If you want something that's really maneuverable like a fighter, the closer you can get it to being unstable but controllable, the more maneuverable it's going to be. So we looked at this. Computers really, pilot moves the stick, computer moves the airplane. It says, okay, I know what she said. She said pull back hard and go fast. If I pull back hard and go fast, she's going to die. So I'm not going to do that. I'm going to pull back slow, and we'll get over to where she wants to go, all right? So that's heavily augmented. And a lot of airplanes that we fly in the military today are successful as a result of some of the work we did on the X-29. But you have to work really hard to fly this thing, so that's kind of why I use it. Last piece of advice, next slide. Don't be afraid of failure. And that's, I know you may think you know what I mean. What I mean is don't not take a difficult course because you're not going to get an A. Okay? I'm just telling you stuff I went through. I wanted to play football when I was American football, okay? Not soccer. I didn't know what soccer was growing up in South Carolina, to be quite honest. But I wanted to play football. My father was my high school football coach, but I was a little kid. And frequently, you know, you will decide I don't want to do something because I'm too small, or I don't want to do something because people will laugh. I decided I never thought I was going to be, I never wanted to be an astronaut. I'll tell you, this is a true story. Never dreamed of being an astronaut. Never. I saw a program on television called Men of Annapolis that talked about life at the Naval Academy. In 7th grade, I decided that's where I want to go to college. I want to go to the United States Naval Academy. That's all I knew. And I worked really hard to get in there. And as I got closer to my senior year, and I got into my senior year, it was looking like I was not going to be able to go to the Naval Academy for a lot of different reasons. I was growing up in the segregated South. You had to have an appointment from a congressman or a senator or a representative, and that was not going to happen. And I was staking all my hope on then Vice President Lyndon Johnson. And unfortunately, my senior year in high school, President Kennedy was assassinated. My hope of becoming a midshipman at the United States Naval Academy went with that, because I knew that Lyndon Johnson was going to become the president, and I wasn't eligible for a presidential appointment. But I didn't give up. I just wrote to the president, and I said I want to go to the Naval Academy. I didn't get anything back from him, but I didn't expect to, but I got a visit from a Navy recruiter who said, I understand you're interested in going to the Naval Academy. Long story short, I ended up getting into the Naval Academy. But even going through that, believing what my mom and dad said all the time about you can do anything you want to do if you put your mind to it, just get prepared and then go do it. When it came to flying in space, becoming an astronaut, I did not believe that. And so I grew up knowing about the space program, watching humans walk on the moon when I was in flight school, but never thinking I could do it. And I, fortunately in my life, when I was a test pilot, I met a guy named the late, great Dr. Ron McNair. And Ron McNair, for those of you who follow the American space program, was a member of the Challenger crew that we lost in 1986. And he came to visit the Navy's test pilot school at Patuxent River, where I was at the time. Found out he had grown up in South Carolina, African-American just like me, except the big difference was he had always dreamed of being an astronaut. And he had always believed he could be an astronaut. And he went to a school called North Carolina A&T, majored in physics, went on to MIT, got a PhD in laser physics, and went on to become an astronaut. And when we finished talking that weekend, he said, hey, are you going to apply for the space program? I said, not on your life. And he said, okay, I don't understand. Why not? I said, they never picked me. And he looked at me just like I'm looking at you. And he said, that's the dumbest thing I ever heard. He said, how do you know? How do you know that they won't pick you if you don't ask? Well, the reason I didn't ask was because I was afraid to fail. I did not want to have somebody else tell me, no, you can't be an astronaut. You know, no sense in dreaming and doing that because it's not going to happen. That's a very simple example of being afraid to fail. Not asking for something that you really want because you don't think you're going to get it. So my lesson or my message in that is anything you want to do in life, ask for it. Get prepared, study really hard, work really hard, but ask for anything you want, because very seldom is somebody going to come in off the street and say, okay, I want you to be an astronaut. I know you hadn't been thinking about this, but we need for you to be an astronaut. So do that. Next slide. No questions? Man, you guys are tough. Yes?
How did you change your mind?
Ron goaded me into it. My mom and dad were career educators. They're both looking down on us from heaven now, but they had told me all my life, you can do anything. Don't ever let anybody tell you you can't do something. You know, don't let the color of your skin, anything, keep you from doing something you want to do. And I was embarrassed that in all the other things I had done, I had lived by what my mom and dad told me. But this one thing, I had decided, I can't do that. And Ron said, when he looked at me and he said, that's the dumbest thing I ever heard, and how do you know if you don't ask? I mean, it just took me back to my mom and dad. And I applied. And lo and behold, I got nominated. I was an active duty Marine, so the Marine Corps nominated me to NASA. NASA invited me to come to Houston for an interview. It's a week-long process. They picked 200 people out of this year. We had 6,300, believe it or not, we had 6,300 applicants for the astronaut program when most people around the world think we're not even involved in human spaceflight anymore. But there are at least 6,300 people in the U.S. who know that we are and applied. And we're probably going to pick 10 or something. I don't know. When I applied, we had 6,500 that applied, and I was just blessed. I was fortunate enough to be among the 200 that they invited to come to Houston and interview. And I finished my 1 week, and I went back to Pax River, and I told my wife, that was incredible. But there is no way in the world that I'm going to get picked for that. I mean, I met guys with PhDs and all other kinds of Ds and everything. And I said, you know, there's so many people they can pick. But the thing I learned once I had been selected and I got there and I was in a position where I was helping to interview people was we're looking for people who are flexible. And for people, we're looking for somebody, in America we have a term jack of all trades and master of none. We were essentially looking for somebody that's a jack of all trades, somebody who is incredibly capable in a particular area, but has the flexibility to be able to go and do whatever it is you want to do. We had medical doctors who flew on the space shuttle, never did a day of medicine after coming into the space program because we didn't need a doctor. We needed somebody who could do some material science experiments. I'm going to show you a picture of me doing a blood experiment, and I'm not a researcher at all. I was a test pilot. But I had the flexibility to listen to somebody who was a principal investigator, try to understand what the objectives of their tests were, and then go be their eyes, ears, and hands to do their experiment on orbit. So anyway, that's an image that I love. It's taken from my Hubble Space Telescope mission. We were about 600 kilometers above Earth, the highest we've ever been in a circular orbit of Earth. Now, you notice I said a circular orbit of Earth because I don't count the missions to the moon. But in Space Shuttle, we were at 600 kilometers when this image was taken. Anybody know what it is? Yeah. It's Egypt, the Saudi Arabia, it's the Middle East. An incredible, violent part of the world. And yet from space, what do you think about that? I mean, it is just so peaceful looking. And it's like everything from Earth, from space. You look back at Earth from space, and it is an absolutely incredible view. Just unbelievable. You can't tell that people live there. You know, you're far enough away that cities are not apparent during the daytime. Even big cities, they may appear as a gray blob or something like that. You can see long linear features, rivers, roads, runways, those kinds of things the human eye picks up, but no people. And so you get this feeling of really being insignificant when you look down on the planet and you say, man, if I were a Martian and I were on this transit to this planet that look Martian-like because I'm looking for life elsewhere in the solar system. And I get 600 kilometers away from Earth and I see this, I might take my spaceship and turn away and go look for another place that's inhabited by an intelligent life form. Except you do see these long linear things, so you start to wonder about them. Those are roads, bridges, superhighways, all that kind of stuff. But it's just an incredible planet on which we live. And you ask yourself, why in the world is it not really the way it looks? And it causes you to realize that it's not because of us. We just don't do well, you know. We're not good at people things. And so you talk about feeling like you failed, and you come back and you really want to do something different to make sure that we do get along a little bit better, and we do things a little bit better, and that we make our world a little bit more like this. So next one. That's Hubble. An absolutely incredible instrument. Absolutely incredible. It's an observatory. People call it the Hubble Space Telescope, but it has 6 instruments on it that are fully functioning now after the last servicing mission. Absolutely incredible observatory. Next one. That's Saturn. Don't pay any attention to it. It's a Hubble image. I show you that. Kids like it a lot. But the colors are artificially generated because I think atmospheric scientists wanted to know, okay, what's Saturn's atmosphere made of or something. So the computers say oxygen's that, something's that, other things are that. Next one. This is hanging around. This was from my 3rd flight in space, and it, like 3 of my 4 flights, it was international in nature. Dirk from out here in the blue was Belgium's first astronaut. He's the Alan Shepard of Belgium. He came on our crew about 6 months before we flew, after we lost another crew member who had been diagnosed with incurable abdominal cancer. This was back in 1991. He is a professor at the University of California, Berkeley this day. So to give you an example of miracles do happen. And then the woman in the middle is Dr. Kathy Sullivan, America's first woman to do a spacewalk. Gravity is overcome when you go to space. You know, traveling 30,000 meters an hour, gravity is overcome. It's still there, but you know, centrifugal force and gravity and all that stuff. And so you float, and you get to live Newton's laws. Body at rest stays at rest unless otherwise acted upon by an outside force. If you do something and start yourself moving across the cabin, you'll just keep going until either you hit a wall or somebody grabs you or you stabilize yourself or something. The human body adapts to almost anything. We were talking a little bit earlier about the human immune system, how it stops working when you get in a microgravity environment. And so you think that the human immune system's shut down and it's never going to work again. After living and working in space the way we do now on the International Space Station, where a crew is there for 6 months, we find that after some period of time of inactivity, the immune system wakes itself up, and then it comes back, and in most people, it becomes hyperactive. And so where it wouldn't do anything before, now anything at all, a speck of dust or anything causes you to get rashes and stuff like that. What we think, and we don't know, again, is that, you know, it may do this kind of thing, come back up, get hyperactive, and then settle out. But we don't know that. We don't know enough. Okay? Next one. That's the experiment I was talking about, doing a blood experiment. We trained a year for this because we had to be licensed phlebotomists. We had to be legally qualified to draw blood. And this was Franklin Chang Diaz and me. Every other day we switched. One day I'd be the patient, he'd be the blood drawer. And then we did that for 9 days. And I've got all these test tubes full of blood that he had taken, and we put them in, you know, spun them down in a centrifuge and then put the blood fluid in a freezer to bring it back and everything. So just trying to see how the body changes over the course of a 9-day mission.
Why does the immune system shut down?
We don't know. Just something about microgravity caused it to do that. And then we really don't know, like I was saying, because we now live and work in space. 9 days on the space shuttle, that's not living and working in space. That's a camping trip. You know, anybody can tough it out for 9 days. We always thought that. We found it out when we started flying with the Russians on Mir for 6 months, and now flying on the International Space Station for 6 months. That's living and working in space. So we're not exactly sure. And I was asking the Vice Chancellor, because the Science Research Center here, one of their focuses is immunology. And I was just curious to know whether there was any experimentation going on the International Space Station in that area because of my experiences with the human immune system. Yes?
What's the longest that humans ever been in space?
Ever been in space? In one time? 366 days, a Russian cosmonaut for that. And another guy with whom I trained once, Vladimir Titov, was there for a year, for 364 days. But I think it's 366 days. But that's just those two have been the longest. Normally people stay for 6 months now on the International Space Station. Next one. And coming up on you got to do that. That's brushing my teeth. You do normal things.
What's the expected lifespan of the International Space Station, and what's its replacement?
The International Space Station, the 5 member agencies have agreed that we will, based on President Obama's recommendation, that we extend its life to 2020, minimum. We have now done all the engineering analysis that says that ISS can take us to 2028 if we want to do that. So we know that from an engineering perspective, we could fly ISS till 2028. Follow on, we don't know. Nobody's really talking about it. My belief is that because we're working right now on trying to develop or facilitate the success of a commercial space capability in the United States. That's private companies that can take people to space, can take things to space. We have a private company in America that wants to build modules and essentially build stations. If we're successful in doing that over the next few years, you won't need an International Space Station run by a government. You can have private enterprises. What kind of stuff can they do? Pharmaceutical development, materials science, materials processing, because you have this environment of microgravity where things really behave differently, and natural occurrences happen, you know, things form the way that they're intended to be formed with the absence of gravity.
So the next
I think there are all kinds of...
might be at private corporation space station, not a government one.
I think that's a possibility. That is a hope of mine, is that the next time you see somebody build a space station, it won't be NASA, it won't be a single nation. It'll either be a conglomerate of nations the way we did this one, or even better, it will be a commercial entity where somebody's doing it for commercial enterprise. And I mean, you know, you all are flying stuff up there to be worked on or do observances or whatever. Was there a question over there? Yes.
What happens to fire?
Next slide. When's what?
Like fire, like flying? What happens to flying when
Oh, what happens to fire? We do a lot of, and I, you know, I never did a fire experiment in space. They're very contained in a firebox, and we find that the flame behaves differently depending on how you have it oriented in a microgravity environment. It doesn't do what you would think, though, where you don't have convective flow inside the shuttle or station. Most of the time, it's just stuff is forced, but it behaves a little bit differently. Yeah. But it does behave. Yes, that's the bathroom. Next one.
The space station after you stop using it?
What will happen to the space station when we stop using it? The plan is that we will either use something like the ATV, the European module that's there now. It's an autonomous transfer vehicle, or we'll use a commercially available vehicle. It will dock to the International Space Station and then use its engines to deorbit the station. And the way we do it, same way we did the shuttle, you'll turn it around backwards. And even station has a front and a back, but you'll turn it around such that the engines fire retrograde to slow it down a little bit. You slow it down by 400 meters an hour, and gravity will begin to take over and pull it back. It takes us 8.5 minutes to get to space in a spacecraft. 8.5 minutes and you're on your way to Earth orbit. It takes an hour to come home because we slow ourselves down. Gravity grabs you, pulls you back half an hour just to get to the atmosphere, and then you start coming down through the atmosphere. Next slide, as a matter of fact. That's me in a launch and entry suit. These are the windows of the shuttle during re-entry. The first 15 minutes or so, I mean, the vehicle's really heating up. The tile on the outside are really heating up in excess of 3,000 degrees and on the outside, and it just glows white hot. And what you see in the front windows is gradually you see this, it gets lighter and lighter and lighter, and then it just completely obliterates your ability to see outside until the vehicle stabilizes and the temperatures go down again, and then you land. So that's the way we're going to deorbit the International Space Station. Put a vehicle on it to make it retro fire, and then a planned re-entry probably into the Pacific Ocean, or the pieces of it that don't burn up. Yeah. Probably another 2 questions or something, and then we got to go.
Yeah,
Next slide.
Commercial entities have been involved in space probably since about the 1950s. So what's really preventing them from launching manned capabilities themselves?
Nothing. That's the point that President Obama made when he said we should now follow the National Space Act, or I mean, even when NASA was formed, the National Space Act that formed NASA in 1958 talked about utilizing maximum advantage of commercially available capability. And it's just President Obama's the first president who said, okay, we're going to do it. And so what we're doing is we're a partner right now. We're making the initial investment to help them through their development, getting their vehicles certified and everything else. We're probably 3 or 4 years away from having a company that can, on their own, build a human-rated vehicle. NASA has never built a human-rated spacecraft, never. The Space Shuttle, Apollo, Mercury, Gemini were all done by American industry, and we collaborated with them. But industry has always been the way we've done this thing. But it's always been, we bought it, we operate it, and everything. That's what costs money, is when you buy it, you own it, and you have to handle the infrastructure. We're not going to do that in the future. The only difference is the acquisition process. We're going to rent it or lease it. Question right there.
Is there a rehabilitation program for the astronauts when they come back to Earth?
Is there a
Rehab program?
Oh, like, is there a rehab program? Yes. When I was an astronaut back in the 80s and 90s, nobody really cared. That's not true. We didn't know what we know now. Remember, I said we were camping back then. So when astronauts went to space, even when they went to the moon, the mission was days long. And on the moon, you were not in a microgravity environment. You were actually in a gravity environment, so you didn't even go through the kinds of things that humans go through on the space shuttle over a 9-day period of time. 2 days to the moon, a couple of days on the surface, 2 days back. You know, you're only in a microgravity environment for two-day periods of time. Not enough for the human body to really get accustomed to being in microgravity. Coming back from shuttle, you had a week's worth of time that you had to readapt muscularly. And the big thing is your neurovestibular system, your balance mechanism that goes to sleep, doesn't work. Coming back from the International Space Station 6 months, it's a little bit longer adaptation. So it may be, used to be 2 days. Today it's sometimes a month. But we have a training regimen, a re-adaptation regimen, physical exercise, other kinds of things. So we have what the baseline data said you were like before you left, and we keep you under rehabilitation until you get back to the way you were before you left. One more question, and I appreciate it, but we're going to have to let you go home, right? Oh, got to go here.
How much does the costume weigh?
I'm sorry, Thomas, tell me one more time.
The space costume weigh.
Oh, how much does it weigh? The launch and entry suit that I showed, the orange one, weighs about I want to say it's 85 pounds, but that's just for inside the shuttle. So you're wearing this 85 or inside Soyuz going to space. Now you got this 85-pound suit on that's there just in case something goes wrong. So you have this cocoon in which you live where you can breathe emergency air until you get back to Earth or get back to the atmosphere. If you do a spacewalk, and I didn't show you any spacewalk images, but if you do a spacewalk, the suit weighs pounds, it's 300 pounds. Kilograms. 130 kilograms? Okay. But a lot. Okay? But again, in space, gravity is overcome, so when you don the real spacesuit, it's weightless. It doesn't weigh anything, but it does weigh. It's still a mass that you're having to move around. And it's pressurized, so it's pumped up to about 4 pounds per square inch. And that means that just to open your arms, you're having to fight the suit to move and stuff like that. It's like you're in a big balloon that's pressurized to keep you like this. And so if you want to be like this or like that, you've got to fight the suit to get there. So an 8-hour spacewalk is a lot of hard work. You all have been absolutely, give me 2 more slides. Go. I'll let you read that. I'm not going to explain the story very much, but I talked about making the world different. Tell the story? Okay, I'll tell the story. I know they're trying to get home.
It's not me, it's your staff.
Okay. The story, this is a quote from a young African boy by the name of Nkosi Johnson, who died at the age of 12, okay? Not important when he died. The fact is what he did when he lived. He had AIDS. Everybody knows about the disease AIDS. He was born with AIDS because his mother had been infected by his father. She knew she was going to die, so she kind of asked a young white woman, Gail Johnson, if she would take care of her son after she died. Gail sort of adopted him, and from the time that Nkosi could talk, about 4 or 5 years old, everybody in his village of KwaZulu-Natal, South Africa, said he always talked about making the world better, making the village better, doing this. He was, when he got to be your age, Thomas, he was telling people, okay, we need to do this, we need to do that. If we're going to make this a better village, these are the things we need to do. We need to understand people. And as he grew up, he knew he had AIDS, and he knew it was a dreaded disease. In his country at the time, the president of the country didn't believe that this was at all real. And so he found himself actually fighting against his own president in trying to help people understand this dreaded disease. He and his mom ended up traveling all over the world. And when he got to be about 11 years old, an American writer by the name of Jim Wooten heard of him, traveled to South Africa, met him, and talked to him for a little while and tried to understand why he was the way he was. How can you be in the condition you're in, no money, anything, and yet you're always so positive and upbeat? And Nkosi told him, you know, I might be poor, I may be black, I may have AIDS, but we're all the same. And that quote became, we're all the same, became the title of a book on Nkosi's life that Jim Wooten wrote a year later. He went back to the United States, thought everything was, you know, he just kind of thought about Nkosi, but didn't give it a lot of thought. And he got a phone call one day and said, hey, Nkosi's going to die. He's probably got another few days. And Jim Wooten got on an airplane, rushed back to South Africa. He said when he got to Nkosi's bedside in the hospital, Nkosi was laying there. He weighed about 12 pounds. He weighed about 20 pounds, not 12 pounds. He's a 12-year-old, weighed about 20 pounds. Sores all over his body, just beautiful black skin, pus and stuff, almost skin just drawn, but this beautiful smile shining through this picture of pain. And he said Nkosi was smiling and he still telling people do this, do that. And Jim Wooten said, Nkosi, I don't get it. He said, you know, you're going to die. And he said, Nkosi looked at him and smiled and said, yep. He said, but you could die today. He said, yep. He said, how can you do what you do? He said, you have never complained. You've never cried. Everybody knows you're in pain. And yet you're always thinking about other people. I don't get it. And he said, Nkosi looked up at him and he smiled and he told him this. He said, you do all you can with what you have and the time that you have and the place that you are. So I will leave you with that message. Individually, we may not be able to do anything. But when you join together collectively and you decide you're going to make a difference, you can. But you got to remember, God gives us just a certain amount of time on this earth, some much more than others. Nkosi was here for 12 years, made an absolutely incredible difference in that 12 years on earth because he decided he was going to do something. So that's what I'll leave you with, and thank you all very much for allowing me to take you down.
Very much, Mr. Bolden. Very inspiring words. Thank you for your time here. We have a little gift. We've run out of time for questions, but we do have a gift we'd like you to.
See, I told you, ask questions. Ooh, thank you, thank you, thank you.
Souvenir from your...
Fantastic. Ooh, I love it. Thank you very much. Thank you. I love this. Now my, my daughter-in-law will be jealous because she graduated from the University of New South Wales, and I have a hat. I will, if it's okay with you all, I'll wear her hat and your shirt. Will that be all right? You'll look somewhere else. Thank you all very much. Thanks so much. Thank you.